Hi class. Today we're going to be looking at section 8.5, which is systems of inequalities. We're going to look at linear and nonlinear inequalities here. And again, we're going to be using our Desmos graphing calculator to get all of our graphs. And then just make sure you sketch a good picture, pretty accurate picture for each problem, and then answer the question if it asks for more. All right, so example 1, which corresponds to example 6 in your textbook. Oops. All right, is a linear system of inequalities. So we're going to type them into Desmos. I've pre-typed them here to save us some time. So x minus y is less than 1 looks like this. And I want to point out a couple things. If it was just x minus y equals 1, we just see that line there. But when it's an inequality, we have a couple other things we have to do. We have to shade in one direction above or below our line. And then we also have to think about whether or not the line is going to be solid or dashed. So as you can see here, our line is dashed because our function is strictly less than 1 and not equal to 1. So that just less than makes a dashed line. If it was less than or equal to, it would be solid. All right, and then the next equation in our system is this one here. So when you sketch your graph, I want to make sure that you do go through the correct intersection point, and then that you have solid and dashed lines where they need to be, and then just shade where the overlapping shaded regions are. So you can see that the overlapping shaded region is in this little top corner part. So I'm going to draw a quick sketch of that. My intersection was at 3, 2. So 1, 2, 3, 1, 2 is my intersection. I have a dashed line going, and I'm going to get one more point so I can get this to be accurate at -1. Okay, so I have a dashed line going there. And then I have a solid line that crosses through 4, 1, 2, 3, 4 on the y-axis. It's nice to make sure that you have somewhat of an accurate graph. And then my overlapping shaded region is this part here. Now it says give 2 possible solutions to the system above. So possible solutions are any points, there's infinitely many of them, but any points in that overlapping shaded region. I would suggest not using any points on the line, because when there's a dashed line, technically those points aren't solutions. So I would just stick to points inside the shaded part. So if we look at, say, this point right there at 3, 1, 2, 3, 4. So I can say that the point 3, 4 is a solution to the system above. I can go on the y-axis if I want. I can use this point here, and that's going to be the point 0, 5. You can choose any points in that shaded region, but the solution of the system is actually just the graph. So the graph is the solution. And then if they ask you to give 2 possible solutions, or I guess I should say the graph is the answer. I don't know, kind of weird to say that, but yeah, if it just says solve the system, then your graph is the solution. If it says give 2 possible solutions, then they want 2 possible points. That might work. Okay, so example 2 says sketch a graph of a system of linear inequalities that has no solutions. So if I want a graph of linear inequalities that have no solutions, one way to do that is to have 2 parallel lines. And then for the shading, it's not enough that they're parallel, actually. It has to be true that the shading goes opposite directions, that the shading doesn't overlap. So there is one way of having a system with no solutions. All right, example 3, we have a parabola and a line. So let's look at what that looks like. All right, so here's my parabola at x squared minus 4, and it's greater than or y is greater than or equal to this. So you can see that my shading is there and my line is solid, or my curve is solid. All right, and then we have the line x minus y is greater than or equal to 2. So my points of intersection, I want to make sure to get those right, are going to be 2, 0, and -1, -3. So 2, oops. Oh my goodness. Sorry about this. Okay. So 2, 0, and -1, -3. So that's going to be my line. And was my line solid or dashed? So we can look at this. This is solid. I can also look at Desmos, but I don't want to have to switch my screen back. All right. And then I have this one was also solid. So if we go back up, just in case you missed it, this was dashed because it didn't have the little or equal to symbol on it. All right, and then my parabola goes 1, 2, 3, -4, and then it goes up from there, crosses right there, and right there-ish, and then my overlapping shaded region is just in that little spot there. So here is my solution to the system. Again, it says give 2 possible solutions, so I want any points in that section. So for example, the point 1, -2 would be a solution, or the point 0, 1, 2, -3 would be a solution. But the solutions are any points inside that shaded region, and there's infinitely many of them. All right. Moving on to example 4, we have 3 equations this time. And when we graph that middle one, so remember, these are going to be vertical lines. If you have x equals something or x is less than something, you get a vertical line. If it's just a y, it's going to be a horizontal line. And if there's an x and a y, that's when you get your diagonal lines. So let's look at what this looks like. All right, so x minus y is less than 2. Looks like this. X is between -2 and 4. So we can see what that looks like there. Notice the left side on -2 is solid, the 4 right side is dashed, and then y is less than 3, it goes there. So my overlapping shaded region is that trapezoid shape in the middle there. All right, so graphing this, I need to know how to graph this line here. I need to make sure that my corners are, I don't need that point, but the -2, -4, and the 4, 2 are going to be important points here. So -2, -4, 2, 3, 4, and 4, 2. 1, 2, 3, 4, 1, 2. So that's going to be the 2 points I'm going to use for my dashed line. And then I haven't been doing it, but we really should be labeling at least a tiny bit on our axes so that I know that I'm scaling my x and my y axes by 1 if we want to be totally complete here, which we should. All right, and then I have x is between -2 with a solid line and +4 with a dashed line. And then y is less than 3, so that's going to be a dashed line up at y at 3. And then my overlapping shaded region was in here. All right, 2 possible solutions, 0, 0. I use that whenever I can. And let's call it 1, 1. Sure, would be a possible solution. This, by the way, when we start getting systems that kind of look more like this, where we have horizontal, vertical lines, diagonal lines, all kind of together in a bunch of them, it's getting us ready for the next section, 8.6, which is linear programming. And that's when we're going to step up the level of difficulty by a lot. But linear programming is the whole reason why, or one of the reasons why we learn systems of equations. We'll see that in the next lesson. All right, last example. Just to see another one here, we have x plus y is less than 2. X is between -2 and 1, and y is greater than -3. So again, I want to look at the points of intersection, kind of where my trapezoid in the middle there, again, it's a trapezoid, it comes. I'm going to use these 2 points, -2, 4, and 1, 1, to draw my diagonal line. What was that? -2, 4, -2, 1, 2, 3, 4, and 1, 1. To draw my dashed diagonal line. And then I have x is between -2 solid line and +1 dashed line. And y is greater than -3 is going to be a dashed line. And then my shaded region is going to be right in there. And again, we probably should label at least a little bit here so I know what I'm counting by. 1, 2. All right. And 2 possible solutions. 0, 0, again, is a nice possible solution. We could have a -1. +2 is a possible solution. There's lots of different examples you could give there. And that's it for this lesson.